Hey, welcome back to our lesson about volume with circular solids. All these are just 3D objects that have a circular base. Something I want to start with is this radius and diameter. You know, when you were a kid and you were learning how to write, and you'd get this lined paper that had, a dark line up here, and then this dash line in the middle. And, you did your radius starting at that, we used to call it a clothesline. And your diameter, though, is from the top all the way down to the bottom. So I'm hoping that might help you remember that the radius is half the diameter, right? And this diameter, if you took this radius, it would take 2 radius to equal 1 diameter. Okay, so we definitely have to keep that in the back of our mind and be flexible with that thinking, okay? Okay, so for the note catcher, tried to give you some illustrations so you didn't have to make those, and we'll kind of make it a fill in the blank kind of situation. Everything's going to be based off the relationship with this cylinder, right? So this cylinder, if this is, the label for our radius, right? And this would be the height of this object. So I use that capital H for height of a 3D object, right? So for volume of almost anything, it's area of that base, for this circle is the base, times the height of the object. So, we would say how many squares would cover this, but the height would tell us, well, how many cubes would fill it, okay? Okay, so in our situation then with a base that is a circle, our formula is going to be pi r squared, that's the area of the base, times the height. Okay, now everything that we do after this is going to be relative to that. If they had the same circular base, if they had the same height. So height of a cone is typically inside like this, but sometimes you could measure it outside too. It's going to be perpendicular to the radius, right? And the relationship we saw when we did the sugar was that a cone is 1/3 of a cylinder's volume. And I'll put that right there. So we're just going to take the exact same formula and say, well, what is 1/3 of that area of the base times the height? Now another way of saying a third, taking 1/3 of something multiplying by 1/3, is to just divide by 3. So I usually prefer to just say, well, let's do pi r squared times the height and divided by 3. Okay, so really all we're memorizing is this. We hopefully already had pi r squared memorized, and now we know a cone is a third. We did a hemisphere with the sugar, and we saw that the same relationship was true, that the hemisphere is 1/3 of a cylinder's volume. So it's the exact same thing as a cone. So I'm going to write that same as cone. So nothing new to memorize there. And we could say it's 1/3 of the area of the base, pi r squared times the height, or take that pi r squared times the height and divide it by 3. Okay. Now this is one of those situations where it is important to remember that sometimes you're given the diameter when we're talking about spheres, okay? So what is the height? Here, the height would be given to us here or outside or like this, right? Let's go back and mark these. But what is the height? If this is the radius, what's the height of this hemisphere or sphere even? Well, there's a reason why I kind of put this on its side, is so that you could see, relatively speaking, the height, and maybe I use this, let's see it, 2 radii, the diameter is the height. Okay, this is really important. Okay, so the diameter in a sphere or hemisphere is the height of that hemisphere or sphere. Okay, so that's kind of important. Okay, we could write it over here. Diameter equals the height. We could also say the diameter equals 2 radii. So if that's, an issue, maybe you prefer to not use height in your formula. Maybe instead of height, you put diameter in there. That will be up to you. Okay. And then we saw, just kind of common sense that if a hemisphere is a third, it would be double that for a sphere, right? So 2/3 would be our relationship here, that the sphere is 2/3 of a cylinder's volume. And I'm going to say in here, or a hemisphere times 2. So really, one formula for all of these, multiply it by, 1/3 or multiply it by 2/3. All right. So we could say, 2/3 of the area of the base, pi r squared, times the height. And remember, we could instead use diameter. Or we could do, we think of the invisible denominator here. It could be 2 pi r squared times that height divided by 3. And again, that could be diameter instead. And now I'm going to give you one last formula, and I'm going to explain it here in a minute. But for now, let's just jot it down. And that is 4 pi r cubed over 3. I used to be really against memorizing this formula because it's like, why would I go and memorize a whole other formula when, all I need to do is keep this relationship straight, right? But it is kind of, it's not too hard to memorize. I used to just remember, oh, there's a 4 when we're talking about sphere and these 3's. But why? Where did this come from? Well, if we take what we just had with the 2/3 pi r squared times the height, and that's our volume for the sphere. Okay, well, we also said that we could substitute the diameter for the height. And we also know that the diameter is the same as 2 radii. So I've substituted for the diameter 2 radius. Now if I rearrange this, do the 2 times the 2 times the pi times the r squared times the r to the first, right? And all of those invisible ones. Do you see how I'm going to simplify this to get 4 pi, add my exponents, r cubed over 3. So this is one you, again, might want to use. It's a little faster, but the key to this, again, is to recognize that the diameter and the height are the same, and not to forget that the diameter is 2 radii. Okay, so when you're doing your practice, make sure you realize what information is given to you and what information you need, so that you're not just plugging in any numbers that are provided, okay? All right, good luck with that practice. Let me know if I can help.